Hello everyone. Today we will explain to you about type of air compression. Basically compressor are broadly classified into two, which is positive displacement compressor and dynamic compressor. There are two types of positive displacement compressor, which is reciprocating and rotary screw. The uses of positive displacement compressor is to increase the pressure of the gas by reducing the volume. Dynamic also divided into two, which is centrifugal and axial flow. The uses of dynamic compressor is to increase the air velocity, which is then converted into increased pressure at the outlet. As you can see there, compressor is divided into two, which is dynamic or is known as centrifugal and positive displacement. Under dynamic or centrifugal, there are two, which is axial and radial. Under axial, it have one stage, which is multi-stage. Under radial, they will have a single stage. For positive displacement, there are two, which is reciprocating and rotary. For rotary, they have roots blower and screw compressor. Under reciprocating, there are six types of them, which is single cylinder, non-lubricated, lubricated, multi-cylinder, single stage, and multi-stage. In our syllabus, we will only cover with positive displacement compressor as shown below. Displacement compressor will be divided into two, reciprocating and rotary. Under reciprocating, there will be piston and diaphragm. For piston, there are actually two types of piston. For rotary, there will be a vane and screw. Now we will see what is piston compressor. As I said just now, piston have two types, which is single acting and double acting. For single stage piston compressor, air taken at atmospheric pressure is compressed to the required pressure in a single stroke. Piston move downward, and this will cause pressure lower than atmospheric pressure, and the air enter the cylinder through inlet valve. It will move upward, and the inlet valve closed. The air is compressed. This will forcing the outlet valve open, discharging air into a receiver tank. Now we will show to you how this piston works.
A reciprocating compressor compresses refrigerant vapor in a cylinder using a piston. In a way, reciprocating compressors are like automobile engines. The pistons are directly driven through a wrist pin and connecting rod from a crankshaft. Depending on their size, reciprocating compressors may have one or more cylinders. Multiple cylinders may be arranged in line, opposed, or in a V. In each cylinder, reciprocating compressors have both a suction valve and a discharge valve. These valves give the compressor its ability to pump refrigerant vapor against a pressure difference. They are usually located in the head of the cylinder, in passages connected to the high or low pressure side of the system. Let's follow the compression process in a single-cylinder reciprocating compressor during one complete revolution of the crankshaft. Starting with the piston at the top of its stroke, or at top dead center, the piston begins to move downward as the crankshaft rotates. Because both valves are closed, the downward moving piston reduces the pressure in the cylinder. As the pressure in the cylinder falls below the low side pressure in the suction line, the pressure difference opens the suction valve, letting refrigerant vapor flow into the cylinder. The piston continues down and pulls in more vapor until the cylinder is filled with low-pressure vapor at the bottom of its stroke. Once past bottom dead center, the piston begins its upward stroke. The suction valve closes. As the piston moves up, it reduces the volume of the space in the cylinder, increasing the pressure of the vapor. When the pressure in the cylinder exceeds the high side pressure in the discharge line, the pressure difference pushes the discharge valve open, letting the compressed vapor flow out of the cylinder. This continues until the piston reaches the top of its stroke and most of the compressed vapor has been expelled into the discharge line. When the piston begins its downward stroke, the discharge valve closes. The complete cycle then repeats during each revolution of the crankshaft. This is the mechanical positive displacement vapor compression cycle using a reciprocating compressor. Please take a moment to complete the following learning activity. To continue, make your selection.
Two-stage piston compressor. Okay, this type of compressor have two piston. The first piston is a low pressure. The second piston is high pressure. At first piston, the function is same like a single stage piston. The compressed air then released from discharge valve to an intercooler. Function intercooler is to heat resulting from compression to allow dissipate. The cooler compress air and then drawn into second compression cylinder. It will repeat the same process like at first cylinder, but the pressure is become more higher because second cylinder is smaller than the first cylinder. Okay, this is an example of intercooler. Okay, now we will show to you the comparison between single stage compressor and two stage compressor. Okay, for single stage compressor, the air is compressed one time. The trapped air is compressed in a single stroke with a piston at roughly 120 psi. The limitation is 3 until 7 bar range. The horsepower for single stage compressor is above 6.5 HP horsepower. Okay, for two stage compressor, the air is compressed twice for double the pressure. The trapped air is compressed in a single stroke with a piston at roughly 175 psi. The limitation for two-stage compressor is 15, 20, and 30 bar range. The horsepower for two-stage compressor is the same as single-stage compressor, which is 6.5 HP horsepower. Diaphragm compressor. The diaphragm provides a changes in chamber volume. This allows an intake in the downstroke and compression in the upstroke. Okay, the limitation for diaphragm compressor is between 3 and 5 bar. Now we'll show to you the sample application of reciprocating compressor. Okay, for single stage, the sample application of it is for spray painting, riveting, woodworking machinery. For two-stage compressor, it is for pneumatic robot, spot welding machine, lifting and moving in slab molding machine. For diaphragm is for food processing, pharmaceutical, hydrogen fuel cell station, power plant turbine cooling. Now I will show to you the diagram sealess compressor. Okay, for number 1 is check valve. Number 2 is hydraulic inlet check valve. Number 3, hydraulic position. Number 4, hydraulic overpump position. Number 5, overpump side glass. Number 6 is hydraulic injection pump. The next compressor is vent compressor. Okay, we will begin with introduction of compressor. Okay, compressor is used to increase the pressure of air flow from low pressure to high pressure by using some external energy. Type of compressor. Okay, positive displacement is operated by trapping a specific volume of air and forcing it into a smaller volume. Two basic design for positive displacement is compressor. There are two types of them, which is rotary and reciprocating. Rotary. Rotary compressor have rotors in place of pistons and give a continuous pulsation, free discharge air. They are directly coupled to the prime mover and require lower starting torque as compared to reciprocating machine. They operate at high speed and generally provide higher throughput than reciprocating compressor. Rotary requires smaller foundation, vibrate less, and have a lower number of parts. That means less failure rate. Vent compressor consists of a cylindrical rotor inside a housing with longitudinal slot with radial sliding vents are fit. The rotor is positioned eccentrically within a cylindrical housing from a fixed inlet port to a fixed discharge port. Compressor inlet and discharge valve are not employed in the design. Always compress the gas to the design pressure defined by the manufacturer. The limitation is 1 bar range.
Vane pumps are positive displacement pumps that have a rotor containing sliding vanes which slide in and out of the rotating rotor and seal against the eccentrically designed housing. This allows for the vanes to expand the opening between the rotor and the housing on the inlet side of the pump to bring product into the pump. As the rotor continues to rotate, the vanes then slide back into the rotor, compressing the product out of the discharge port.
Displacement compressor. Okay, displacement compressor divided into two, that is reciprocating and rotary. Under reciprocating, there are piston and diaphragm. Under rotary, there are vane and screw. Screw compressor. Okay, this diagram shows the important part of screw compressor. There are 9 of them. One of them is split piece timing gear, rotor internal cooling bile oil, radial bearing, rotor, male and female, coupling, thrust bearing, casing, cooling jacket, and shaft seal. Okay, this is a more part of screw compressor. That is rotor timing gears, seals, water jacket, oil freeze, rotate set, and bearings. Screw compressors also is known as helical lobe or spiral lobe compressor. The positive displacement rotary design that compress gas between intermeshing helical lobes and chambers in the compressor housing. Do not use valve. Compression ratio is determined by the warp angle of the lobe and the location of the opening edge of the discharge port. Okay, this type of compressor commonly used to replace piston compressor. Screw compressor are best able to accommodate liquid carryover, efficient in low air pressure requirement. Two screws rotate intermeshing with each other, trapping air between the screws and the compressor casing. The compressed air delivery is continuous and quite in operation than the reciprocating compressor. Presently, the industry standard in plant air compressor from about 25 to 300 horsepower, used in large industrial application or to operate high-power air tools such as jackhammer. Okay, now we will show to you the video of screw
MAN
compressor
Diesel and Turbo
operation.
manufactures tailor-made process gas screw compressors for customers, a modular system of tried and tested components guaranteeing the utmost reliability. Depending on its size, a compressor stage can suck in and then compress volume flows of between about 200 and 100,000 cubic meters per hour. All screw compressors operate according to the basic principle of a positive displacement machine, whose key element is a pair of spiral rotors. During operation, the rotors turn and the spiral teeth mesh together, forming chambers between the rotors and the casing wall. Rotation causes the chambers to move from the suction or intake side to the compression or discharge side. These chambers are connected to the suction nozzle via ports. As the chambers enlarge, they are filled with gas flowing in through the nozzle. To understand the compression process better, let's look at an individual chamber. It enlarges, is filled with gas, and then closed by a circumferential edge in the casing. The rotors now transport the gas to the discharge side, where the chamber shrinks and the retained gas is compressed. Let's view the process again, this time from below. Once the gas is compressed, the chamber reaches another port connected to a discharge nozzle, and the gas flows out. In fact, all the chambers between the two rotors are being filled and emptied continuously. This means that with a screw compressor, the compression process is more or less ongoing. The design of a screw compressor combines the advantages of a positive displacement machine with those of a rotating machine, making this type of compressor suitable for a very wide range of applications and process gases. MAN Diesel and Turbo has been developing and constructing process gas screw compressors at its Oberhausen location since 1952.
Okay, now we will show to you the advantages and disadvantages of screw compressor. Okay, the advantages of screw compressor is it has simple design. It also low to medium maintenance and initial cost. It has two-stage design provide good efficiency. Easy to install, few moving parts, and most popular compressor design in plants. Okay, the disadvantages of this compressor is limited air life, high rotational speeds, single stage design have lower efficiency, oil injected design have oil carryover, difficulty with dirty environment, and two-stage oil free design have higher initial costs. Okay, that's all from us. Thank you.